The human brain is the most sophisticated thermodynamic engine in the known universe. To understand emotion, we must evaluate the physical cost of its neural processing, measuring the balance between information flow and metabolic expenditure. Traditional psychological models categorize emotions as subjective states, a classification that separates feelings from the physical constraints of the neural substrate. From a biophysical perspective, the limbic system serves a specific evolutionary purpose. It is an organ of lossy data compression. To ensure survival, the brain must convert high-dimensional sensory data into immediate signals. This compression algorithm discards nuanced information to produce rapid, thermodynamically efficient commands, like the immediate impulse to flee. While this heuristic was efficient in ancestral environments, its design creates a systemic energetic vulnerability. The brain's hardware is now forced to apply these high-speed survival algorithms to the abstract, chronic stressors of the modern world. Modern stressors often lack an acute physical resolution, leading to a state of allostatic load. This represents the cumulative biological wear and tear on the body caused by chronic activation of the stress response. The energetic model of allostatic load suggests that the metabolic burden required to support these stress states begins directly competing with the energy needed for cellular growth and repair. When daily energetic demands exceed the capacity to dissipate metabolic entropy, the organism enters a state of allostatic debt, a deficit that leads to systemic degradation. We quantify this using the entropic brain hypothesis. This scatterplot maps conscious states across neural entropy and functional complexity. Looking at the top right quadrant, hostile cognitive states operate at the absolute maximum of neural entropy, significantly higher than normal waking consciousness. This entropic spectrum suggests a physical divergence in the brain. The data indicates that the brain's long-term structural integrity may be tied to whether it maintains a benevolent regime or drifts into an adversarial one. To measure the informational noise within these states, we apply Shannon entropy. This mathematical formalism quantifies the physical uncertainty inherent in neural microstates. Biological agents exist in a constant physical struggle against the natural thermodynamic tendency toward disorder. This struggle is defined by Carl Friston's free energy principle. The brain resists physical disorder by acting to minimize variational free energy. By doing so, it implicitly bounds the entropy of its sensory states to maintain its own structural boundaries. These emotional states represent divergent thermodynamic cycles. Negative affect functions as an exothermic Carnot cycle, an information-saturated regime that wastes energy as heat while accumulating data about the past. Chronic hostility creates an exothermic feedback loop. It consumes biological resources without performing useful computational work. Chronic hostility is not just an emotion. This high-entropy signaling triggers a literal, neurotoxic biological disassembly program directly within the brain's physical architecture. This chart tracks the biological disassembly cascade. Hostile patterns permanently activate the HPA axis, causing glucocorticoid-induced oxidative stress. The inability to dissipate entropy damages DNA. Chronic rumination triggers calcium overload, activating enzymes that literally dismantle the neuronal cytoskeleton. At the macro level, the hippocampus and prefrontal cortex undergoes significant dendritic atrophy. Conversely, the amygdala hypertrophies, hardwiring the system for further reactive, high-entropy states. In this high-entropy regime, metabolic energy is not used for signal processing. It is dissipated as literal structural damage to the executive architecture of the mind. Benevolence, states of gratitude, compassion, and social connection, functions as an active, low-entropy endothermic regime. This chart maps regenerative coherence. Safety engages a vagal brake, increasing heart rate variability. This triggers splenic acetylcholine release, inhibiting inflammatory cytokines to cool the neural system. Finally, oxytocin boosts antioxidant enzymes, neutralizing stress to protect the system. Positive affect also upregulates brain-derived neurotrophic factor, signaling the system to promote neurogenesis and synaptic plasticity. This benevolence acts as a metabolic subsidy. It redirects energy away from defensive mobilization and toward higher-order cognitive repair and synaptic complexity. To bridge the physics of information with biological reality, we must look at Landauer's principle. Landauer's principle dictates that the erasure of a single bit of information costs a specific amount of energy, dissipated as heat. Hostile rumination creates locked priors, where the brain repeatedly processes high-entropy noise. The brain eventually lacks the metabolic energy budget required to erase this accumulating informational noise. This state of thermo-informational insolvency represents a massive accumulation of allostatic debt. To manage this energetic bankruptcy, the biological system disassembles its most complex and expensive hardware, the synapses of the prefrontal cortex. Benevolence functions as a sophisticated biocomputational strategy to minimize variational free energy. Compassion keeps the brain in an optimal zone of subcriticality, at the edge of chaos. This maximizes informational capacity while preserving structural integrity. Thermo-informational psychiatry views clinical intervention as a method for restoring the physical entropy dial of the mind. Practices like mindfulness and vagal tone training physically recapitulate the reversed Carnot cycle to dissipate thermal waste. Protecting cognitive sovereignty in the modern era requires safeguarding an individual's ability to maintain these coherent, low-entropy states. Hostility is a biophysical error that consumes its own hardware. Benevolence is the regenerative thermodynamic prerequisite for the